Okay, a tank holds 1,000 gallons of water, which drains from the bottom of the tank in a half an hour. The values in the table show the volume V of water remaining in the tank in gallons after T minutes. So we have T minutes goes from 5, 10, 15, 20, 25, 30, and the volume gallons goes from 694 all the way down to 0. In part A, it says if P is the point 15 to 50 on the graph of V, find the slopes of the secant lines PQ when Q is the point on the graph with T is equal to 5, T is equal to 10, T is equal to 20, T is equal to 25, and T is equal to 30. So we're going to be using P, which is 15 to 50 for the ordered pair, to construct the following table. So what we're doing is ultimately right now for each particular point, we want to be able to find the change in velocity over the change in time. That is the slope that we're looking at. And recall that that is the rise over the run. So when we make a table at T is equal to 5, we can take a look up here, and this is the ordered pair. So we have the ordered pair 5 and then 694. So we want to find the change in velocity over the change in time. Well, we take 694, which is the change in velocity for point Q, and then we're going to subtract 250, which is the velocity in point P, and then we're going to divide that by 5 minus 15, which is the change in time. So we end up getting negative 444 over 10, which gives us negative 44.4. Okay, the next point is when we have the time T and the volume is at 444. So we have 10, 444. So we're going to find the slope using that point according to point P, which is 15 to 50. So we take 444 and subtract 250. And then we take 10 and subtract 15. So from here, our values is going to be negative 194 divided by 5, which gives us a slope of negative 38.8. Okay, our next point that we're going to use is then 20 and then 111. And then the next one's going to be 25, 28, and the last one's going to be 30 and then 0. Okay, now let's find the slope for 20, 11, and then 15, 250. So we're going to take 111, subtract 250, and then 20 minus 15, which gives us negative 139 over 5, which is equal to negative 27.8. And then next we're going to take 28, subtract 250, and then take 25 and then subtract 15. So that gives us negative 222 divided by 10, which gives us a slope of negative 22.2. And last, we're going to take 0, subtract 250, and then 30 minus 15, which gives us negative 250 divided by 15, which gives us a slope of negative 16.6, and that's repeating. So here is a summary of the table that we're finding the slopes of the secant lines of PQ when Q is the point on the graph when T is equal to the following. Now, we're going to move to the next question. The next question asks us to estimate the slope of the tangent line at P by averaging the slope of two secant lines. So what we're going to do is we're going to using the values of T that correspond to the points closest to P, because P is 15 to 50. So 15 is in between 10 and 20. So we can use those 2 points. So we're going to go ahead and highlight those. So we have, when closest to P, we have T is equal to 10. So that gives us this slope here. And then when T is equal to 20. So that gives us that slope there. So let's go ahead and calculate the average. So we take negative 38.8 plus negative 27.8, and then we're going to divide that by 2, which gives us negative 33.3. So that is estimating the slope of the tangent line at P, and we averaged slopes of 2 secant lines that was close, so we had 10 and 20, since that number 15 is in between 10 and 20. Next, what we want to do is we want to use a graph of the function to estimate the slope of the tangent line at P. This slope represents the rate at which the water is flowing from the tank after 15 minutes. So we got to come back to our table of values, and what we're going to do is we're going to use Desmos, and we're going to create a table of values. So here we're going to select our table and put in our values for X. So we have 5, 10, 15, 20, 25, 30. And then for the values of Y, we have 694, 444, 250, 111, 28, and then 0. So now let's take a look at our points. So here are our points. Okay, what we want to do is we want to make sure we can draw a line. And by doing that, we're going to go up here and select settings, and then select this dot. And then over here where it says line, we want a line to go through that. Okay, and then the next thing that we want to do is we want to then create our viewing rectangle to go from 0 to 30 for X. So we'll go from 0 to 35. So we'll go 0 to 35 just so we can see that window. And then we're going to go for the Y value, we're going to go, let's say, 0 to, let's say, 750. And then maybe scroll out just a tiny bit here so we can see what's happening with our graph. Okay, so I'm going to go ahead and take this graph . Alright, so here's our graph, and again, the question of what they want us to do is they want us to estimate the slope of the tangent line at P. So we're estimating what that tangent line is going to be on this particular graph. So let's go ahead and draw a tangent line on this graph. Okay, so that tangent line is going to be touching right at that point. So therefore, that would be the tangent line that we're estimating it to be, because that's right on that graph located right here. And then what we're going to do is now we're going to create a right triangle to figure out what that slope is. So here at 400, we're going to go all the way down to 100. Okay, and then what we're going to do is then we're going to then go from here to there. So what this does is this represents our rise and our run. So the rise, we start at 400 and then we go to 100. And again, we're estimating. So we have 400 minus 100, and we know that it's going down. So that's negative 300. And then the run, okay, is not necessarily at 20. It's about maybe at 19. So we can say 19 minus the value of 10 here, which is equal to 9. So now we can estimate this slope. And so estimating the slope of the tangent line at P is taking the rise over the run, which is equal to negative 300 divided by 9, which is equal to negative 33.3 repeating. And so if you notice what that slope of that line represents, well, that represents part B, and what we found to estimate in part B, we got the same estimation here. And so let's just label this. So remember that this represents the volume in gallons. The x-axis was T, which is in minutes. We know that this line represented the approximate tangent line, and this was the graph of the function.